Okie doke, in today's video, we're going to move on from talking about differentials and marginals, but kind of keep those ideas in the back of our mind, and we're going to move on to elasticity of demand. Now, if you've taken any sort of economics class, you may have heard this word elasticity before. So what we're going to do today is we're going to really break down what it means mathematically. Where does it come from? What's the math behind it? And it turns out it's related to derivatives. So, but in order to do this, first of all, I need to be working with a demand equation, okay? Demand equation represents how does my demand, so Q in this case represents the demand for a product. How many products do we expect to sell, okay? Depending on what can we change as a company, we can change the price. Now, I know this might be a little confusing because previously we've had functions where X is the number of products we're going to produce, and then P represents the price, and so we're changing what X is, but remember, variables are always fluid, so we're going to do it anyway. So in order to understand elasticity of demand, we have to understand a couple of important ratios. First, and they're very similar. We need to understand this ratio, and we need to understand this ratio. You'll notice they look exactly the same. I'm just changing the variables for each of them. So what do each of these ratios actually mean? Well, we've seen this notation before, right? We know what the triangle means. Triangle means change, right? So I'm going to focus on this one because price is a little bit more concrete of a concept. So delta X is how I'm changing my price. But if I divide it by X, that means I'm dividing it by what the price is currently set at. So if I were to rewrite this, this is change in price divided by the current price. Okay. Similarly, over here on the Q side, this is the change in demand divided by the current demand. Okay. Well, what does that actually give me? What turns out what that gives me is what's called relative change. For example, right? If I change the price by $1, so I'm upping the price by $1, but my current price is $2, well, this formula right here is going to tell me this is a 50% increase. If you're curious about the 100, that's me converting into a percentage. So this is a 50% increase. And that's a lot different than if I increase it by $1, but my current price is $100. This is a 1% increase. Right? So that's this idea of relative change. If I change it by a certain amount, what is that relative to what it's currently at? Okay. So same thing over here. This is just relative change in my demand. Also relative change, just in my demand instead of my price. How is my demand changing relative to what it currently is? So what elasticity does is it actually compares these two things. How does the relative change in demand compare to the relative change in price? And so to do that, I create another. So elasticity, I write it as capital E of X. I create another ratio. This time I do relative change in demand over relative change in price. Now that doesn't look very pretty, so let's see if we can simplify this a little bit. Okay, well the hundreds just cancel out because I have 100 on top, 100 on bottom, and then I have a fraction over fraction. So to rewrite that, I can just flip and multiply. I get delta Q over Q times X over delta X. Well, Order doesn't matter with multiplication, so I can rearrange this to delta Q over delta X times X over Q. Well, interesting. Interesting. We've seen delta Q over delta X before. All that is a average rate of change formula. And what did we learn in our last video? We learned that the average rate of change, as long as delta X is relatively small, the average rate of change can be approximated using, using the derivative. I can use the derivative to approximate that relative, or that average rate of change. So I end up with this, d prime of x times x over q. Okay. Now there is one more piece to this elasticity equation, and to understand where this comes from, we have to understand how demand functions work. Okay. If I think about a demand function, if you increase your x, right? If you increase price, what can you expect to see with your demand? If you increase the price, it's going to lower the demand. So a demand equation will always have this negative relationship. This negative relationship that if you increase one variable, the other variable is going to decrease, which means that d prime of x should always be negative. Because, once again, whenever you increase the price, the demand's going to go down. If you ever decrease the price, the demand's going to go up. It always has that inverse relationship. So because of that, that means this elasticity will always be negative because your derivative is always going to be negative. Well, we don't like necessarily working with negative functions all the time. So to deal with that, all I'm going to do is I'm just going to put a negative in front of all of this. I kind of put it up by the numerator, but I really should just put it in front of everything. Okay? So that is my elasticity equation. Negative d prime of x times x over q. So let's look at an example of this. Okay, consider the following demanded function. Let's try and calculate the elasticity for this demand function. Okay, well, if I look at my formula, right, I'm going to need to know the derivative of my demand function, right? That's an important part of my elasticity function. So let's go ahead and calculate the derivative. This derivative requires the chain rule. Okay, so I'm going to get 1/2 350 minus x to the 5th raised to the negative 1/2. Multiplied by the derivative of the inside function, which is just negative 5x to the 4th. Okay. Notice that your derivative has this negative being multiplied by it, and that's what gives us that negative relationship, right? It means my function's decreasing. This is a decreasing function. Very nice. Okay, let me clean this up just a little bit. If I clean this up, I get negative 5x to the 4th over 2 root 350 minus x to the 5th. Right, I can just move that to the denominator because it's a negative exponent. Okay, I'm not sure why I changed the color. Oh well. So, now that I have my derivative, I can go ahead and build my elasticity function. Notice my elasticity function has this negative out in front, and that's going to cancel out with this negative. So, and that's what we want to happen. Usually your negatives cancel out so that your elasticity function is positive. So what am I left with? D prime of x is 5x to the 4th over 2 over 300 square root 350 minus x to the 5th. Okay. The negative should be gone because it canceled out with the negative in the elasticity function. But then I still need to multiply it by x. Okay, well that's simple. That's just multiplying it by x. But I also need to divide it by q. Divide by, well, what's q? Q is just your demand function. So I can plug that whole thing in for Q. So to review, right? Here's my X, here's my Q, and this whole thing right here is your d prime of X. After you've canceled out the negative. Okay, let me simplify that a little bit. 5x to the 4th times x gives me 5x to the 5th over, what happens when I have root 350 minus x to the 5th times root 350 minus x to the 5th? You get a square root that's squared, and I'm left with 2 times 350 minus x to the 5th. The square roots go away because you're multiplying the same thing by itself, and the square roots cancel out. Okay. There's my elasticity function. Now this really isn't super helpful unless I actually have a specific x value. Okay. What do the x values mean again? X values are my price. So let me give you a specific price value. Let's say we wanted to evaluate the elasticity at x equals 3. Since it's a price, I'll go ahead and put a unit in front of that. This is $3. Let's say we set the price at $3. Okay. Well, let's plug that into my elasticity equation. See what happens. I get 5 times 3 to the 5th over 2 times 350 minus 3 to the 5th. And I end up getting 1,215 over 214. Okay. Which, if you threw this into your calculator real quick, which I'll do right now, you should get something in between 5 and 6. And let me just double check that. 1,215 divided by 214. Yeah, sure enough, you get 5.68. About 5.68. But what does that even mean? What does 5.68 mean? Well, to understand this, we have to remember that elasticity is a ratio. It's a ratio. It's how does the change or the relative change in demand compared to the relative change in price. If I get 5.68, that means that my relative change in demand is 5.7, 5.5 times bigger than my relative change in price. So if I were to just write this simply, what this tells me is that relative change in demand is bigger than relative change in price. Okay, sure, that's good to know. If I'm the business owner, what does this actually tell me to do? What can we change? We can change the price. So really it boils down to, should I change the price? How should I change the price? Well, let's think about that. If my relative change in demand is bigger than my relative change in price, what happens if we raise the price? Okay. If we raise the price by a certain amount, this elasticity tells me that my change in demand will be more significant. The change in demand is more significant than the change in price. If I increase the price, is my demand going to go up or down? It's going to go down because demand functions always have that negative relationship. They're always decreasing. So if I change my price by a little amount, it's going to significantly decrease my demand. It's going to decrease my demand by almost 5 times as much as I increase the price. Is that a good thing? Absolutely not. I don't want to decrease my demand by that much. So I probably shouldn't raise the price. But let's go the other direction. What if I lower the price? If I lower the price, it's still going to have an effect off my demand, but it's going to have the opposite effect. It's going to increase the demand by almost 5 times as much, or by more than 5 times as much as I lowered the price. Is that a good thing? If I'm the producer, if I'm the company, absolutely. So what does this tell me to do? This tells me to lower the price. Because by only lowering it just a little bit, I can significantly increase my demand. I can change the demand by a lot by changing the price by a little bit. That's what that number tells me. Okay. So let's look at what these numbers actually mean. We actually call this, if your relative change in demand is bigger than your relative change in price, we call this elastic. Okay. So let's go through what each of these things are. So if your demand is, we'll start with elastic because we just finished talking about it. If your demand is elastic, that means that E of X is greater than 1. And what does that tell us? That means the producers should lower the price. Because once again, by just lowering the price a little bit, you can significantly increase your demand by a larger factor. Well, where does it change? Like we said, this changes if E of X is greater than 1, because that's where your relative change in demand is bigger than your relative change in price. So let's switch that. What if your elasticity is less than 1? It's always going to be positive. Remember, that's why we put the negative in front of the elasticity equation, is to make sure that this ends up being positive. So it's always going to be positive. So what happens if your E of X is less than 1? We call this inelastic. Well, what that means is your relative change in price is larger than your relative change in demand. What does that mean? That means you can get away with increasing your price and not changing your demand by very much, and only changing your demand by a very small margin. Okay, what does that tell me? That tells me I should increase the price, because I can increase the price by a relatively larger amount and not take that large of a hit in my demand. So producers should raise the price. Oopsies. Well, we've skipped over one specific situation. What if E of X is equal to 1? What if your elasticity ends up being exactly 1? What does that mean? That means that your relative change in demand will match the relative change in price. Okay? And if that's true, if those two relative changes match up, then if I change the price at all, it's going to have an equal change in my demand, and it's not going to affect my revenue at all. It won't affect my revenue. Same thing if I lower the price. It'll have an equal effect on my demand, and it's not going to affect my revenue. So, should I change the price? No. And usually, we call this unit elasticity. And usually if this occurs, that means we've reached our max revenue. And we shouldn't change the price at all. Don't change the price at all if you're at max revenue. If it ain't broke, don't fix it. Okay. So with a lot of your homework problems, it's just as simple as this, right? Using this elasticity equation, the hardest part is really just coming up with this piece right here, right? Because it requires you to find your derivative, multiply it by x, and divide it by your original function, and then cancel out the negative that's going to be there with the derivative. Okay? But then, based off that elasticity equation, we can plug in a number and make my decision of whether I should change the price or not. So this last piece, this idea of unit elasticity, this begs a very important question. Well, if having an elasticity of 1 means that I'm at max revenue, well, couldn't I just, instead of test different prices, couldn't I solve for a price that gives me this elasticity of 1? And it turns out I absolutely can. So let's look at another example. Take a look at this revenue equation. Oh, I used P for price, and I think this problem on your homework actually does use P for price, and so sure, why not? Let's use P for price. Okay, so let's go ahead and once again, we're going to calculate the elasticity here. And in order to calculate the elasticity, I need to know the derivative of this function. Okay, I can either use power rule here, I can use quotient rule, but regardless, I should end up with negative 400 over P plus 2 to the third power. Okay. If you're curious about where I got that, you can rewrite this equation as 200 P plus 2 to the negative second. And so you can see that you can just get this derivative by using the power rule and chain rule, but the derivative of the inside function is just 1. So, okay, so now let's find my elasticity equation. And since I said my independent variable is P, we got to switch that to P there. Okay, notice your derivative is negative, so that negative is going to cancel out with the derivative of my elasticity function. And what am I left with? I'm left with 400 over P plus 2 cubed times P over 200 over P plus 2 squared. Right? Here's my X, here's my Q, and here's my D prime of X. If I go back and look at my equation for E of X. Okay, so let me simplify this a little bit. I do have a fraction in the denominator, so I can just flip and multiply by that. And what am I left with? 400 divided by 200 gives me 2. I'm left with 2P over P plus 2. If you're wondering where the heck I got that from, let me slow down a little bit. Okay, I get 400 over 200 times P times, once again, if I flip and multiply, then this P plus 2 squared ends up in the numerator, and I have a P plus 2 cubed in the denominator from this. Okay. Well, 2 of the P plus 2's are going to cancel out, and so I'm left with just 1 P plus 2. 400 divided by 200 is 2, and I still have the P there, so I get 2P over P plus 2. Okay, so there's my elasticity equation. At this point, yeah, I could test prices to see which ones will give me an inelastic relationship, which ones will give me an elastic situation, or I could solve for when I'm at unit elasticity by just setting this equal to 1. By setting equal to 1, I can figure out, okay, where am I going to have my max revenue? So, multiply both sides by P plus 2. I get 2P equals P plus 2. Subtract by P, and I get P equals 2. What should I set my price at? I have my max revenue at $2 at a price of $2. Awesome. So it turns out we can also use the elasticity equation this way. I can solve for when I'm going to have my max revenue. Okay. Okay, good luck with the homework. Let me know if you have any issues and have any questions. Thanks, guys.